All right, hi guys, and welcome to another session. So again, we are going on with the MCQ madness. So remember that we did some of the O-level papers in the last MCQ session, and today we'll be looking at the IGCSE papers. Again, we'll be doing questions, mostly the questions that are indicated by the examiner report is what students struggle with, but we'll also be looking at other questions in the process. All right, so let's start. This is summer 23 is what we're looking at right now. Again, these are the homework papers as well. So you guys can also have a look at what mistakes you made. If you had some problems with any of the questions, you can also have a look at these. All right. So let's see. So question number 1, for some reason, is also highlighted by the examiner as a question that the examiner thought was important enough to comment on separately. So which vector diagram correctly shows the force Z as the resultant of X and Y. So it must be obeying the head to tail rule. So X and Y, but here the resultant is not drawn correctly. It should be like this. So A is wrong. X and Y like this. So again, the resultant should be in this direction. Also wrong. C, X and Y in this direction. So here the resultant would be like this, not like this. So it should have been like this as the arrow. So C is also wrong. And D by default is correct because it also has the correct line and it's also the correct direction. Question number 3, what is the distance traveled by the vehicle in 400 seconds? Again, this is a speed time graph. So distance is the area under the graph. So all of this area is what we need. And it's really easy to find out. It's just the area of a triangle. So half base into height. So half into 20 into 400. So it's going to be 20 times 200, which is going to be 4,000 meters. Also really easy. Question number 6 is also easy. Again, for some reason, the examiner has chosen to comment on this separately because this is a case of finding the density of this irregularly shaped stone. This procedure which is shown will give you the volume. So the only other thing you need is the mass, for which you'll use the balance, right? You won't use the meter. All right, let's have a look at this. Question number 7, a train is traveling horizontally in a straight line. A book is on a table in the train. The diagram shows all the forces acting on the book. So there's a contact force on the book, which is upwards, weight, which is downwards, frictional force, which is here, right? So frictional force is to the right. This means that the book wants to move towards the left, right? This is the first thing that you need to identify here because the friction is to the right. So the book wants to move to the left, but we are going to comment on how the train is moving. So first off, if the train is moving at uniform speed, then the book would not move at all, right? There would be no movement in that case. So if you look at question number 7, just a sec. Yes. So if it's moving at uniform speed to the left of the diagram, or if it's moving at uniform speed to the right, in either of these cases, the frictional force would not really be active. Because if it's at uniform speed. This means that acceleration is zero and resultant force is zero, right? So this should then not be moving in any way. So there would not be the frictional force in that case because it has no tendency to move. But right now, if it's not moving, this means that the frictional force is to the right. So it must be moving to the left. And more precisely, it must be accelerating to the left. Sorry, because it's accelerating, because the force is to the left on the book. So if you think about the inertia, the train must be accelerating to the right so that the book is sliding, at least it wants to slide backwards. So the frictional force is forward. So in this case, the answer is accelerating to the right of the diagram. So if you think about it, it's similar to one of those questions where we used to talk about the force on tires when something is moving forward or backwards. Let me just quickly show you that, just to refresh your memory. So remember, questions like these are what I'm referring to. These were one of those unique type of questions in which the direction of acceleration and the direction of friction were in the same direction, right? So it's pretty similar to that. So remember that it opposes motion across the surface. All right. So for example, if a suitcase is accelerating on a conveyor belt, which is a case like this. So in this case, because it's accelerating to the right, because this belt is accelerating to the right, it wants to move to the left. So friction is also forward, right? This is the idea here. Similarly, in the cases of engines and these wheels, it's like this. So IGCSE questions are really not easy. They might be less intensive on the calculation, but as you can see, they are definitely very, very theoretical. Really need to put in a lot of thought into selecting an option as compared to Olympics. Let's see, what were we talking about? Yeah, so it was this one, right? So moving at uniform speed will not cause it to will not cause there to be any frictional force because this would basically be an equilibrium, right? So there would be no frictional force either. And for the book to basically try to move to the left, the frictional force is to the right. So if you think about inertia, if it's basically going to slide to the left, the train must be accelerating to the right. That's the idea. This is also not really difficult. If you write this out, you will find that you can very easily find which one is going to be not in equilibrium. You just use the principle of moments. For example, you see here 6 times 1 is clockwise, 3 times 2 is also 6, it's anti-clockwise. So this is equilibrium. And similarly, you keep doing this for the beam in which the anti-clockwise, clockwise moments are not equal. All right. Let's have a look at 10. Again, the examiner has chosen to comment on this separately. Which row about the change of energy in the energy store must be correct? So the process is water pumped up to a high altitude dam. Gravitational potential energy of water and change of energy in store increases, right? So if you think about this as well, question number 10, which says water is pumped up to a high altitude dam. So this means that obviously the height is increasing. So GP is increasing. So this is absolutely correct. Nothing wrong with it. Water pumped up to a high altitude dam. Again, kinetic energy of water decreases. Again, does it necessarily have to be correct? And the answer here is no. For the kinetic energy, if you think about it, if this water is pumped up to the dam, so if it's being pumped up, maybe because of this pumping up, the kinetic energy could also increase, right? Because if it's if you're using a high pressure pump to bring it up, then it could be speeding up. So kinetic energy could be increasing. So it doesn't necessarily have to be correct. Air passes through a wind turbine, GPE of air increases. Again, we know this is definitely not true because air hits the turbine horizontally and it basically makes it move. So uh, it basically has to do with kinetic energy. It has nothing to do with gravitational potential energy. So D, air passing through a wind turbine and kinetic energy of the air increases. This is obviously false as well. That as the kinetic energy of the air is going to be passed on to the wind turbine because it's making it rotate, the kinetic energy of air would decrease, not increase. So that's why in this one, A is the correct. This one, for some reason, has also been highlighted by the examiner. I don't think it's really all that difficult. It's just half mv squared. And then you make V the subject, right? So yeah, we just need to make sure that we take the square root at the end as well. Question number 13, again, not very difficult. We just need to use P equals to rho G H, all of which is given. This is rho, this is H, and G is 9.8, right? So that's how you do 13. 14, a student uses a microscope to observe pollen moving on the surface of water. Again, this is something which is related to IGCSE. It's not O levels anymore. This is the idea of Brownian motion. This statement describes the reason for this movement. Water molecules are moved by microscopic pollen particles. So basically, you know that this provides the evidence for the random motion of particles. So water molecules are moved by the microscopic pollen particles. This is not true. Water molecules are moved by pollen molecules, also not true. It's the pollen particles which are moved by the water molecules, right? That's the reason for this, because of the continuous movement of the water molecules, which make it move. All right. Next. We have 18. First things first, in any question related to refraction, do have a careful look as to whether the angles are marked with the normal or not. If they aren't, then you have to do it yourself. Here, one angle is with the normal, the other one is not. So this one is going to be 40 degrees. And then you just use sine of angle in air over sine of angle in the medium, which is sine 40 over sine 25. So that's it. Again, 19 is not really difficult. It has to do with you just recalling the lenses cases. So right now the object is placed beyond 2f. So this leads to an inverted diminished image, as you can see. And then it says it's moved to point Q. So that's between f and 2f. So this would lead to the same sort of image, would have the same properties, except that this would be magnified. So this would be enlarged, but this would still be inverted. So it's just going to be B here. Let's see what else do we have here. 21. Visible light has wavelength in these ranges. What is the range of frequencies? Again, not really difficult. You have V equals to F lambda. We can just find out both of these frequencies and make a range out of these. That's going to be V over lambda in both cases. So V is 3.0 into 10 to the 8 over one of these lambdas. So this is 3.0 into 10 to the 8 over 4.0 into 10 to the negative 7, which is 7.5 into 10 to the 14. So it's obviously this one then. So it's D. 22, student X fires a starting pistol which produces smoke and sound. Student Y is standing 100 meters away and sees the smoke the instant it is produced. Speed of sound is 340. What is the time delay between student Y seeing the smoke and hearing the sound? All right. So seeing the smoke is basically going to have to do with really seeing the light, right? So that's going to be according to the wave speed, the speed of light. So V equals to distance over time. So the time for seeing the smoke, which is basically seeing the light, this is going to be D over V. So the distance is going to be 100 over 3.0 into 10 to the 8. I expect this time to be smaller because light travels faster than sound. So 100 over 3 into 10 to the 8. So that is 3.33 into 10 to the negative 7. And then if I do the same thing, but for sound now, so hearing the sound, so it's going to be 100 over 340. So 100 over 340 is going to be 0.29. So 0.29 minus this very, very small value is also going to be approximately the same thing again. Let's see 23 now. So permanent magnet, soft iron. So the polarity at X is definitely going to be something which causes attraction. So north is the closer end to it, so it must be a south. And direction of force on the soft iron because of the attractive nature of induced magnetism is going to be to the left. So that's going to be C. All right. Next we have 25. So a wire has uniform cross-sectional area. Which statement is correct? So we know resistance is proportional to length over area. And I've also taught you guys this, that if someday the examiner does ask you about the diameter, so it's really area is proportional to the square of the diameter. So resistance of wire is directly proportional to cross-sectional area. Wrong, wrong. It's directly proportional to length, inversely proportional to cross-sectional area. True. It's inversely proportional to the square of the diameter, not just to the diameter. So this is also wrong. A battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.4 amperes in the circuit, and the battery supplies a total of this much of energy, which rho gives the charge that passes and the EMF of the battery. So charge, we can see it's just going to be current times time. So current is 0.4, time is 1 minute, so that's 60 seconds. So 0.4 times 60, it's just looking at the table, it's going to be either of these. And EMF of the battery. So basically, if you have the charge now, you can just use this. So it's 48 divided by 24, so it's going to be 2. So the answer in this case is C. All right, the next one, the examiner now asks is question number 30. So question number 30, as you can see, is related to an AC generator. So it shows you an AC generator. It shows you the graph of potential difference versus time. Positive value of PD indicates that X is more positive than Y. All right. So X is this ring and Y is this ring. All right. So let's see here. So which diagram shows the position of the coil at point P on the graph? So let's first really try to understand what it means by X being more positive than Y. So this means that a positive value of PD means it's like this, right? This is the positive value, and then vice versa. So what it means for this N to be positive is basically this, that current must be flowing like this, right? Current must be flowing like this because we know it always flows from higher to lower potential. So this is how current must be flowing. So if you look at this current flowing throughout the same coil, it's going to be going like this. All right. So it says which diagram shows position of the coil at point P on the graph. So point P is where the EMF is negative, right? So potential difference is negative. So this means current must now, in this case, be flowing the other way around. So in this case, the current must be flowing like this, 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 and this. So for this current to be flowing in this way, we now know the direction of the induced current. We also know the direction of the field. So using that, we can find out the direction of the force on this conductor, right? So now I just use my right hand rule because this is a generator. I need to Oh, so here we do know the direction of rotation as well, right? So this is how it's rotating. So if I use my right hand rule, so let's say I am now considering this end, right? So I'm looking at this end. So it's because this is rotating clockwise like this, the force on this one is upwards. So force is upwards and north to south. So my index finger of my right hand must be pointing to the right. And what I would find is my current is flowing inwards, right? So in this position, as you can see, it must be going in this direction, right? It must be rotating like this. So here, if we see, so this is a minimum, right? But it's not zero EMF. So we know that the vertical position of the coil induces no EMF because it's moving parallel to the field lines. So it definitely has to be either of A or C. But now how do we decide between A and C? So it really has to do with the direction of the flow of current. So as we just saw, the current is going like this for this EMF to be negative. So this current, if we look here, yeah, so if I again label here as well, so it's like this and this and this and this and this and this. All right, so for it to be flowing downwards through Y, the current must be flowing, if I make the same direction here, be like this, 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 and hence it's going to go like this through Y, which is downwards, and then the rest of the stuff. So C is correct. Now let me show you why A is wrong. If I make the same direction of current here, if current goes like this, then you can see that it's going like this and then upwards through this resistor, right? So now it's going positive to negative, which should have corresponded to a positive potential difference, but this is very clearly a negative potential difference. So it should be C. Again, a really technical question. All right. So that's the answer to this. Then let's do 31. So an arrow moves into a uniform magnetic field. The arrow shows the initial direction of motion of the electron. The direction of the field is into the plane of the page. In which direction does a force act on the electron when it enters the field? So we know this, that the Fleming's left-hand rule tells us that the force acting is mutually perpendicular to the current as well as to the field. So if current is like this or this in this case. I'll get to that in a moment. And the field is into the page. So for that to be perpendicular, it must either move upwards or downwards. That's just what my left-hand rule tells us. And now we figure this out, that because this is a negative charge flowing into this field, so my direction of conventional current I would take to the left, because that's how we define conventional current, as the flow of positive charge. So now when I use my left hand rule, my middle second finger must be pointing towards the left, and the uniform magnetic field is into the page. So that must be inwards. And hence I would see that my thumb is, so my thumb, just a second. So my thumb is going like this. So it's going to be, oh, sorry, I striked off the wrong ones here. So it's going to be towards the bottom of the page. It's downwards. All right. Can't be into or out of the page because it has to be perpendicular to both of these. And if the field is into the plane of the page, so it definitely can't be along those directions. Have a look at another one. 32, which statement about transformer is correct? There is an alternating current in the iron core from the primary coil to the secondary coil. This is not true. Current doesn't actually flow through the core. B, an alternating current in the iron core produces an alternating current in the secondary coil. If you think about it, this is an alternating current in the iron core. Again, it's not in the iron core, so this is wrong. An alternating current in the primary induces a direct current in the secondary, also wrong. Both are alternating, which is given in D. An alternating current would basically also lead to an alternating voltage, which is why this is true. Have a look at another one. So a radioactive source is placed near a detector connected to a counter. 210 counts are recorded by the counter in 3 minutes. This basically means 70 counts per minute. And the background count rate is 20. So what is the corrected count rate? So 70 minus 20, it's going to be 50. Right? Also not really difficult, because you've done more difficult questions than these regarding half-lives. Next, we have 36. Background count rate measured by a radiation counter is 40 counts per minute. With the counter close to a radioactive source, the counter reading is 960 counts per minute. Right, so 960, and there's the 40 from the background. So it's really, the initial count was 920, and half-life is 20 minutes. What is the reading 1 hour later? So 1 hour later means 3 half-lives, so it would half 3 times. So 920 over 3. 920 over 2 is 460. Then this divided by 2 is 230. And then after the third half-life, if we divide it by 2 again, that would make it 115. This is just because of the source, and there's still going to be the 40 from the background. So 115 plus 40 is going to make it C. All right, so you also have to subtract it, then do the half-life calculation, and then add it back in. (38) A space station orbits the Earth at a distance of 7,000 kilometers from the Earth's center. It makes 15 orbits in every 24-hour period. So if it's 15 orbits in 24 hours, I can figure out the time for one orbit, which would just be 24 over 15, right? It's simple math. So that's 1.6 hours per orbit. So for the speed of the space station, I then have the distance, 7,000 divided by the time period. So that's the distance, right? So the speed is basically the average orbital speed. So 2 pi r over time 1.6. So 2 pi times 7,000 divided by 1.6. So 38 turns out to be 27,488. So it's D. 40, which stages in the life cycle of a star are listed in the order that they occur. So first of all, we have if you look here, so we have an interstellar, option A says an interstellar dust cloud, which becomes a stable star, which then becomes a protostar. This is obviously wrong. The protostar stage happens first. Protostar, red giant, stable star, also wrong. Red giant comes later. Red giant, white dwarf, protostar, again, that's strong as well. Stable star, red giant, white dwarf, this is correct. And it's basically detailing the latter parts of the life of a medium-sized star. So this was also a pretty technical paper. Let's have a look at this one, Summer 23, paper 23. Let's see what the examiner highlights here. Question number 2. Which statement about a falling object accelerating close to the Earth's surface is correct? Close to the Earth's surface is basically indicated so that you can think about air resistance. The weight of the object is increasing, force of air resistance is decreasing. Wrong, the weight is not increasing. Weight of the object and force of air resistance on the object are of equal magnitude and act in opposite directions. This could very well be true, but let's think about this. But again, no, it can't be true, right? Because it's accelerating, so forces cannot be balanced. So this is wrong. So it really has to be a case where the object has weight, it also has air resistance, but at the time that it's accelerating, the weight has to be more than the air resistance. So the weight of the object is constant, force of air resistance is increasing. This does seem correct. The weight of the object is less than air resistance. This can never happen, so it is this. Next, we have 3. An aircraft is moving at 60 meters per second north when a crosswind from east starts to blow. Speed of the wind is 13. What is the magnitude of the aircraft's velocity when the wind is blowing? So it was moving with 60 like this. And the crosswind starts to blow from the east. So that means it's going towards the west. This is 13. This is 60. Right? This is 13, this is 60. Oh, sorry, I made a mistake. It's 60 in a north direction. And there is this wind from the east which blows. So this is 13. And this is 60. And the resultant velocity is really going to be this, the straight line, the magnitude of which we need to calculate. So it's going to be the square root of 60 square plus 13 square. So let's do that. This turns out to be 61.39, so 61. All right, question number 6. A cyclist is traveling in a straight line along a horizontal road at constant speed. The constant driving force F acts on the cyclist in the forward direction. So it's at constant speed, so we know that the forces are balanced, right? So there's no acceleration, so there's no resultant force. Constant force F is forward, so there must be an equal force backwards. So the magnitude of, which statement about the magnitude of frictional forces is correct? So 6A magnitude is equal to F, this is correct. Otherwise, if it was any other case, he would either be accelerating or decelerating. Easy. Let's have a look at 8. So 8 says the diagram shows the minimum force F1 acting vertically on a lever required to lift a heavy log of weight up. The log needs to be lifted by a force smaller than F1. The diagram shows the changes tried. Each diagram is only one change from the original diagram. In each case, F2 is the minimum force required to lift the log. So F1 is the force which is going to lift the log, right? And we need to decrease this force F. This is right now the minimum force which does lift this log. We want to decrease this force. You can see this pivot is marked. If you see here, this is producing a clockwise moment. This is that minimum force. If I think about the moment, this was that minimum moment required, right? So if I want the moment to be same, but if I want to decrease the force, I would need to increase the distance from the pivot. All right. This is thinking you need to do before yourself, before seeing such a big question and just being puzzled by all the information the examiner throws at you. So in each case, F2 is also the minimum force required to lift the log. P, increasing the length of the lever to the right of the pivot. As you can see, this does increase the distance. So this is definitely a change that would work. Applying the force perpendicular to the lever. Right now, this force is not being applied perpendicularly to the lever. So as a result, if you think about this force is right now, not all of it really goes into producing a moment. If you basically do the opposite of taking a resultant, if you break this down into two perpendicular components, it would be like these, with each of these components being smaller than F1. So right now, this component is smaller than F1, and that's what is really producing the moment. So if you now apply a force which is perpendicular, because this force is perpendicular, this can produce a greater moment. All right. If you don't like this line of reasoning, you can also think of it like this, that always the force for a moment, it's the force times the perpendicular distance. Here is the pivot, so this is really the perpendicular distance. Right, so this is the perpendicular distance in this case. But now if you have the same force but applied perpendicularly now, you can see that now the perpendicular distance is definitely larger, right? This is obviously larger than this one. You can also just pick it up and show you side by side with this. So this is definitely larger. So P would also work, Q would also work, increasing the distance from the log to the pivot. So if you increase this distance, that just decreases this distance, right? So this is not what we want. This would decrease the moment. So in which situations will F2 be smaller than F1? So it's P and Q, definitely. So this has to be B. This was that entire question. Again, this is also very technical. Let's go on to another one. It's to 9 now. At this point, you should really be accustomed to tackling questions of these types. You might not even need a diagram to do this now, but anyway, I'll make it just for clarity. So this object of speed 16 meters per second strikes, it rebounds with a speed of 12. Mass is given, time is given. You need to find the impulse experienced. So impulse is delta P. You have two formulas, F delta T, and just the change in momentum because there's no force, no time given. So you just have to use mv minus mu. Because this is a change in direction, you define a sign convention for yourself. Take velocities to the right as positive, velocities to the left as negative. This is your final, this is your initial, so just mv minus mu. So 0.25, because 12 is to the left, it's going to be minus 12 minus 0.25, and this is to the right, so it's plus 16. So it's really 0.25 times 28, if you can see the algebra happening here. So that's 7 Newton per second. Right? Whenever you have cases of rebounding, this means that the direction is reversing. All right, now let's have a look at 11. Research is being carried out to produce electrical energy from fusion of nuclei, which row shows two of the problems in designing a fusion reactor. Temperature needed would definitely have to be very high. That's what happens in stars, so that you can overcome the electrostatic forces of repulsion. So nuclei are positively charged and they repel each other. Easy. Let's have a look at 13. Diagram shows how pressure due to a liquid varies with depth. Beneath the liquid surface, small g is given. What is the density of the liquid? So this is pressure due to the liquid, so that's not the total. So atmospheric pressure is not in here. This is just the liquid pressure. So we can just calculate this using rho GH. So here we see we have this value, which seems to be right on point. So this is 4,000. Density is what we need to find out. G is 9.8 and the depth beneath the surface at this point is 0.5. So you just divide it here. So 4,000 over 9.8 times 0.5, and that turns out to be 816. So 820 corrected to us. All right, let's go on to another one now. 16. Two otherwise identical cars, one black, one white, are at the same initial temperature. Cars in left and right, sunshine and their temperatures increase. During the night, their temperatures decrease. Which car shows the greater rate of temperature increase? Which car shows the greater rate of temperature decrease? Temperature increase would basically be the one which is the better absorber. So that's black. And temperature decrease, and again, it's just the rate. It's not talking about the actual temperatures. Just the rate of temperature decrease is going to be also greater for the black car because it's a better emitter as well, right? Good absorber is a good emitter. So it's black here. So it's 16A. Let's have a look at 17. A drop of water from a tap falls onto the surface of some water of constant depth. Water waves spread out on the surface of water. Which statement is correct? So water waves are definitely not longitudinal. They are transverse and travel at the same speed in all directions, or they travel more quickly in one direction than in the others. The answer is they travel with the same speed in all directions, which is why the spacing is the same. Otherwise, the spacing would be more somewhere and less someplace else. '18, you just see this word magnifying glass. This only happens in case 6, in which the object is placed between O and F, which causes a virtual magnified upright image to be formed. Next, we have 22. Again, really easy. For an electromagnet, we have iron because it's a temporary magnet. Easy. Then we have 25. Student does an experiment to investigate resistance of a wire. The graph shows the results from this experiment. This graph that you see here is of inverse proportion. So resistance is basically inversely proportional to this quantity X. So is resistance inversely proportional to diameter? No, it's inversely proportional to the square of the diameter. But again, we shouldn't strike this out because it could be the case here. Resistance is proportional to length, so it's not this. Resistance, again, does not decrease as temperature increases. Resistance increases. And again, this is a metal wire, so it's assuming it's an ohmic conductor. So the resistance would not really increase or decrease. It should have stayed constant if it obeys Ohm's law. Again, resistance does not decrease for a current in the wire of a metal wire as well. it is the diameter of the wire. The reason being this, that since resistance is proportional to length over area, I can say resistance is inversely proportional to area. And because area is, I can write it as pi r squared, or in terms of the diameter, I can write it as pi d over 2 square, which would lead to pi d square by 4. So what this leads to is the idea that area is proportional to d squared. So as proportions, I can also say resistance is inversely proportional to the square of the diameter. So that's why this is true. The cost of electrical energy is 0.25 for each kilowatt hour, 2200 watt heater switched on for this time. What is the cost of this use? Again, you just need to multiply the watts, the kilowatts and the hours. So converting this into kilo means dividing by 1000. Converting 48 minutes into hours means dividing by 60. So you just do this and the answer should be A. Let's do some of the other ones. 27, I think this is pretty easy. Let's have a look at 30. The diagram shows a wire hanging freely between the poles of a magnet. There is a current in the direction shown. Magnet and current cause a force to act on the wire. In which direction does this force act? Again, field lines would be left to right, so it's in this direction. Wire, the current is in the downward direction. So the force, again, by the left-hand rule, as you can see, it would be mutually perpendicular to this and to the field lines. So it would either be out of the page or into the page. So I know it can't be left or right. Right? It has to be perpendicular to the current as well as to the field lines. Now, if I use Fleming's left-hand rule, my current is downwards. Field lines north to south are to the left. So that's how my index finger points. So my thumb points outwards at me. So this is out of the page. Just a second. Current is down. Oh, sorry, I messed up. Current is down. I kept it as up. So this is into the page, right? With your left hand, your middle finger must be pointing down, your forefinger away from you to the left, and the thumb is then going to be pointing into the page. All right, what do we have next? Let's see. Easy. Transformer has 5500 turns on the primary, 500 on the secondary. Output is 110 volts AC is connected to a heater. Transformer is 100% efficient. The heater produces a power of 132. What is the current in the primary? So because I know the I know the voltage in the secondary, I can also figure out, because I know the power, I can figure out the current in the secondary as well. So P equals to VI. So current in the secondary is this, which would be 132 over 110. So that's 1.2 amperes. This is IS, but I need IP. So for this, you can use the turns ratio. So NP over NS should equal IS over IP. It flips for the currents. So 1.2 times 500 divided by 5500 is 0.109. So 0.11. Which conclusion does not follow? So this does follow from it, that most of the atom is empty space. So most of the mass is in the nucleus. This also follows. This does not follow. We only know that the nucleus is positively charged. We don't actually know that whether it contains neutrons or not. Let's see what else do we have here. So with changes occurring in a nucleus during beta emission, we have discussed this in a lot of detail time and again. Let's do it once again just to refresh your memories. So an electron is 0 minus 1. Then going from here to here, the proton number must increase by 1. So there must be a proton here, 1, 1, and this must be a neutron, 1, 0. So it's a neutron turning into a proton and an electron. So that's C. Question like this we have done. Which statement about the orbit of comets is correct? Let's have a look at this. So comets have elliptical orbits, sun is at the center. Comets have elliptical, sun is not at the center. Comets have circular orbits, sun is at the center. Comets have circular orbits, sun is not at the center. So first of all, comets do not have circular orbits. They have elliptical orbits, and the sun is not at the center, right? So that's the answer to this one. '40 is again an IGCSE only question. Which quantity can be determined using the brightness of a supernova? So the brightness of a supernova can basically allow us to calculate the distance of the galaxy from the Earth. The amount of redshift can allow us to calculate its speed away from the Earth. And then using both of these together, we basically calculate the H naught values, right? The Hubble constant values. Yeah, so that's it for these two papers. And then in the next session, we'll be looking at the winter 23 IGCSE papers. All right, and then we'll be going back and seeing how much we can actually do. So that's it for this session, guys. See you next time. Bye.